So welcome to the August 25th Arborist call, first one we've had since Econ 3. The last one 2 weeks ago, we just opted out of because everyone was pretty much wrapping up Zcon 3, and traveling back and had the opportunity to kind of sync up in person. So that was incredible. Hate I missed that, but wasn't able to travel due to a family issue. Yeah, so meeting format, same as always, quick little intro. We hear from the node team, Zcashd, Zcashd, and then we just kind of have an open discussion period where we can talk about anything that is kind of topic of the day. In the case of like network upgrades, obviously we're talking about timelines, coordinating around activations, et cetera. In let's call it network upgrade periods, we talk about ongoing development, R&D issues, et cetera. Arborist calls are all about the protocol. We talk about, again, kind of covered this, R&D, timelines, et cetera. The purpose is to just make it more accessible and transparent for people in the community that just like to keep up with what's going on at the protocol level, or might have questions about what we're working on at the moment. Anyone can participate, just register for the call and feel free to join us. You're welcome also to present if you have a protocol related topic, just let me know. Or if there's something that you'd like, the team to discuss that's on the call, you can also just let me know and we'll slot that topic in, at a future call. So, all right. Other ways to get involved. I always like to throw this up. Beside the joining the Arborist call, we have a wonderful community grants program. If you're interested in doing anything with Zcash, I would encourage you to check out the zcashcommunitygrants.org website. They all kind of information on there about what they're interested in funding. Although they are very open, it doesn't mean that your idea has to be on that list. It's just some suggestions. It talks about how to apply, et cetera. We also have a joint Falcoin and ECC grant program. We have the website up now. And it's for projects that kind of have some benefit to both Falcoin and the Zcash ecosystem. So projects that might span both chains in some fashion and be additive. And then of course we have the R&D Discord, which is where the bulk of all of our engineering discussions take place. We also do call coordination in that Discord as well. So you're welcome to join us there. And with that, I'll pass it over. Usually Conrado does the update, but whoever's going to do the update on the Zcashd side today.
Hey, so we just rotated the Zebra team lead a few weeks ago, so that's me now. Okay. So as you might imagine, it's been a slow month for Zebra development because we were all helping run a conference. But we've mainly been doing some preparations for a release candidate. So looking at getting our testing all sorted, doing some dependency updates, some minor performance improvements, those kinds of things. So that's what we've been looking at on the Zebra side. There's a few minor fixes to the network protocol, but yeah, we're mainly looking towards the next few releases where we're hoping to be ready for a release candidate. So that's where we're up to. The last release, which I think Conrado might have spoken about, we made a number of breaking changes to the configuration and a number of performance improvements, but I think we've already talked about that.
Okay, excellent. Yeah, and one thing I meant to say kind of at the beginning, I think everyone on this call, at least the panelists were, physically at Zcon 3. I was remote, as I mentioned, and, I just wanted to give a huge shout out to the people that worked to put that on. Like the experience for someone attending virtually was just absolutely first class. Like it was as good as any virtual conference I've ever been to. Just the quality of the stream, the sound, the organization of, what was coming next, et cetera. It was just really, really well done. So
that's great.
Good to hear.
Yeah, hats off to anyone. And I know, I may not pronounce her name right, but Danica or Danica, I'm not sure exactly how to say her name. Just the communication with, speakers and everything. And the coordination was just, it was totally well done. So yeah, kudos to everyone involved in that. And I know I saw like a lot of the engineers were doing like session coordination and you know, kind of the MC and fielding questions, and that was awesome as well. So yeah, great job. All right, so Zcashd, kind of give you a bit of an update on a few things. Yeah, that was my first slide. So one of the things that's been kind of top of mind for us for a couple of months now, a little over, is an increased network load. So since mid-June, and I know everyone on this call is pretty much aware of this, but I'll just kind of do it for folks that might randomly watch a recording at some point. But since mid-June, there's been a significant increase in shielded transaction load. And we kind of looked at the impact of that load kind of across, kind of across what's called the ecosystem. So like on the Zcashd side, like what I call node operations, like the ability to run a node and, you know, the peer-to-peer network kind of thing, they were not that impacted, with the exception of, you know, block propagation maybe took a little longer because blocks were, you know, full, et cetera. Miners and exchanges that interacted directly with Zcash through a full node wallet, they were impacted primarily by elongated scan times, and in the case of miners, increased orphan rates. And then mobile wallets have been the most severely impacted. And in some cases, wallets just had severely impacted scan times or failed to sync altogether, depending on how recent you had synced your wallet. These wallets are primarily like Edge, Unstoppable, and Nighthawk, the ones built on our SDK, which relies on, you know, the SDK's syncing capability. And they're, I believe, you know, in most cases, Y Wallet and Zec Wallet Lite, you know, perform fairly well. You know, I know there was some cases where it did work for people, didn't work for people, but by and large, I think they functioned, you know, and have been functioning pretty well. So, you know, that's kind of the load. And what we're talking about for folks that might not know, this is kind of like a 3-month snapshot. So, you know, historically, our shielded transaction load is kind of down here on this blue line. And then starting mid-June, it really kind of popped up. And from mid-June until right in here, this was primarily an increase in Orchard transaction load. And then it kind of dropped off. And then when it resumed, you know, kind of the increased load, it was all sapling. And then here it has dropped back down. But these are transaction rates. So the number of transactions have gone down. So if you look at like the shielded transactions, kind of, you know, and again, you can't tell a ton about them if they're shielded, other than like the number of inputs and outputs or actions in the case of Orchard. In this window here, where the blue line's clearly above the black line, those were a larger number of transactions that would average, you know, a little over 100 outputs, sapling transactions that would average a little over 100 outputs. And where it kind of dropped off here, the load is kind of still there, but the kind of the profile of the transactions have changed. So the transactions now will be, you know, in some cases, a little over 1,000 outputs. So it's fewer transactions, but each transaction has significantly more output. So the rate's gone down, but kind of if you want to kind of think of it as the net is roughly about the same in terms of what has to be done to verify or validate a block. Chain growth, as you might expect with that kind of increase,
wow,
is getting close to having tripled since mid-June. So somewhere in here, we were about, this is not an interactive graph, so it's not going to do the tooltip thing for me, but I think roughly like 30 gig or so, something like that. And we're about 83 right now. So chain growth, because of the on-chain data we're storing associated with the, you know, the shielded transactions, has really kind of kicked the chain up in terms of size. So that's kind of what we're, you know, kind of current state of affairs. So I have that slide in there twice. Never mind about that. So on the protocol side of things, our priority's been on mitigating the impact of this increased load. So we made some performance improvement to transaction verification times, block propagation times, and Zcashd full node wallet scan performance. Got some great partners we worked with. In a lot of cases, they would grab in, you know, a branch, like a development branch we were using, just to go in and see if it, you know, had the effect that we intended. So we really appreciate all their help in verifying some of these things that we had in development. You know, that kind of resulted in a couple of Zcashd releases, 5.10 and 5.20. 5.10 had an 80% decrease in block validation times for sapling and orchard transactions, and then some improvements to mining related RPCs to help reduce orphan rates. Zcashd 5.20, kind of the highlights there would, continued improvements to reduce block propagation times, and then significant improvements to Zcashd full node wallet scan performance through primarily increased parallelization. So the combination of those two releases, performance at the node level is not, it's not what it was pre-increase in load, but at this point, orphan rates have come down. They're not down as low as when a block's essentially has very low utilization. So they're in the, like 1.8 to 2.8% range, according to some feedback we've got from our partners. They were at one point as high as 8%. And then we haven't had anyone, and we have some partners with some incredibly large Zcashd wallets, sometimes in, several 100,000 addresses in there. So because you can imagine like scan performance could be quite impacted in that case. But there, scan is slower at the Zcashd level, but it's nothing that prevents them from operating effectively. So yeah, a couple updates there. On the mobile side, now I know this is a protocol focused call, so rarely do we talk about anything outside of that, but since this is somewhat, highly related, I did want to talk about some things that we're doing on the mobile side to kind of address this load, because it is kind of a network level load we're seeing. So the near-term goal that we had prior to this load for our wallet team was to call, quote, harden our mobile SDKs by including things like an updated FFI layer, improved syncing capability, which was always on our roadmap, and then other APIs needed for our wallet and other apps using the SDKs. So what we did is we bumped the faster sync up in priority over the other items we're going to include to try to get that out sooner, so that the partners, in the case of the ones that use the SDK, Edge, Unstoppable, Nighthawk, will get their sync performance, within what we hope is acceptable levels. The faster sync algorithm, we don't have it developed, we don't have benchmarks, but our expectation is that sync time will go from, several hours or days, depending on when you synced your wallet last, down to less than an hour, and we hope significantly less than that, but again, it kind of all depends. ECC's focus as a company, we're looking at this holistically and not just from an engineering perspective. So the number one thing for us, like we know there's a sync issue in our mobile wallet SDK. So that's the priority for engineering. It's kind of all hands on deck for that. In parallel, we're doing outreach to all of our ecosystem partners to make sure they're aware of what we're doing around these issues, and to understand if they have any lingering node level performance issues that we may not be aware of. We're shifting our research efforts at the moment from proof of stake, which is where Nate's been spending the bulk of his time, I'm sure you saw his excellent presentations at ZCon 3, over to like fee mechanisms, or fee changes that would be consistent with our roadmap if possible. We've always, kicked the idea around of some kind of EIP 1559-ish kind of thing, obviously not a direct port, but, or not even a direct conceptual port, I should say, but something along those lines. So Nate's all in on doing that, and we'll be reaching out to different people to discuss. I know Addy has a zip proposal in as well, so Nate's got it on his list to chat with him about that, just to kind of fully understand it. Whatever we do though, however, fee mechanism or otherwise around, to try to help this, we want to kind of holistically evaluate any change in terms of its impact to user experience, and how you would actually adapt that change, like in a mobile wallet, for example, or what impact it might have on mobile wallets. Because we want to make sure that anything we introduce doesn't potentially cause, like, call it collateral damage, in the sense of it causes other problems, in the mempool, because transactions are flowing. If you want to send shielded funds, you can. It's going to get through, not a problem. Some things we could do might, yes, address a symptom, but it would potentially impact people that are trying to use Zcash. So we have to really evaluate, kind of in totality, not just the engineering mechanics of how we would do something. So, so those are some items, a few more. We're also doing like user research. Some of the growth team at ECC has been sending out like surveys to try to understand better some of the issues people are seeing, their experiences with different wallets, so we can summarize that, get it out to the ecosystem. And then, yeah, so just other research efforts related. And then prioritize changes that improvise or improve, it should say, improvise. Yeah, definitely not improvise, improve long-term network resilience. So, kind of like phase 2 of this is to identify, okay, are there other things that we know could potentially be a problem, and we've kind of kicked the can on it a bit, and we're going to look at getting those addressed before they actually become problems. So so kind of that's kind of a summary of like the things we're doing both on the engineering side, kind of across the company. It's kind of an important issue, and I just wanted to make sure that we kind of got that out there for everyone. So that is, yeah, so that was my last slide. I'm going to stop sharing and see everyone that way. Yep. Okay. Anyone have any questions or comments or anything on any of that? Let's see. No hands or anything.
Yeah, that's fair.
I think someone said something, but I couldn't quite make it out.
I tapped this, but that was communicating with someone else in the room.
Oh, no problem. Okay. Okay. No problem. Yep. All right. Cool. All right. Okay. Very good. Well, that's back to Taylor's comments. We had a good bit of people like at DEF CON and then traveling back. So I mean, we've been doing a lot, but that's kind of the summary of like our focus over the past couple of weeks anyway. So all right, anyone have anything else?
Yeah, the other thing we're doing is trying to, so there has been a fork of Zcash that has been, is it Zcash? I'm not sure, that was used in the wallet SDKs, and we're trying to get everything unified so that it's using the latest version of Zcash.
Oh, right. Yeah, getting back on. Go ahead, Strat.
Yeah, Stephen mentioned that at the beginning of the wallet section, which was just the unification pieces, because there was some drift between the two pieces, and it's taken a fair bit of work to sort of reify those, because it's difficult to keep backporting like performance changes we're trying to make on the main branch to the branches that the SDKs are actually using. But that work is almost done. And then the performance work will be able to build directly on top of that. And
sorry,
I might almost be.
I hadn't heard that Stephen had already mentioned it.
Yeah. And the goal of that then, hopefully we will even be able to get to the position of having a new release of the Zcash client backend and Zcash client SQLite crates, which has been a while, because they've been sort of in a halfway position of like refactoring, and we've just not been able to get them to a stable enough point to release. But I think with after we've done these changes, we might possibly be close enough to be able to do that. So.
And there will be some API changes, but hopefully they shouldn't be too difficult to adapt to.
Yeah, I think our plan there is to kind of like consume the SDKs with our internal wallet apps and just kind of really wrap our head around kind of what API changes there might be, so we can work like directly with folks to help streamline their kind of adoption of the new SDKs. So.
Right, yeah, for the mobile SDKs, yes.
Yeah, mobile SDKs, right? Yeah.
Yeah, because the other thing there with the mobile SDKs is that this upgrade will also be the one that transitions the mobile wallets to using unified addresses.
Right. Yeah.
So the first cut of that will be the one that people migrate to the internal wallets will migrate their data formats to the viewing keys that are the unified viewing keys with transparent sapling and orchard components. and any key material that people maintain around that will need to be migrated as well, and that sort of thing. So that will be like a heavier upgrade for people to migrate to, but necessarily because that would have to happen anyway to get to that. But the migration plan will be there once we've done the tested against the internal wallets. And then from that point, the subsequent releases that add more performance and things should be significantly easier to switch to.
Right. Cool. All right. No, excellent points. Yeah. Now, just point of clarification, adding unified addresses does not necessarily mean having Orchard support in there, or does it? In the mobile SDK?
Correct. So
okay, yeah.
the moving to unified addresses, what that will do is the unified spending keys and things will be migrated to use to have Orchard, and it will potentially mean that you could actually receive funds to the Orchard component, but it won't have any spend support at all.
Okay.
And in fact, we may initially even remove the Orchard component from the address component, so that at least in that first iteration, the addresses UAs people are giving out don't include the Orchard component, while they don't have the ability to include it as part of the balance, because that won't be in the next SDK release. Right. But the spending key side will have the Orchard components in there, so that this back end migration that some wallets may need to do of their spending material will just be done once to have the Orchard piece.
Right. Okay. Excellent. A little bit of a
once
lesson
we've done all
learned.
The performance things, then then Orchard will come directly after that.
Right. Yeah. A little bit of a lesson learned from the protocol there. That would have, in hindsight, probably been a great way to have rolled out unified addresses first, and then like Orchard maybe in a subsequent upgrade or something. But hey, that's water under the bridge. It all worked. It's all out. So anyway, cool. All right. Thanks, Strad and Dara, for that clarification. All right. Anyone, anything else anyone wants to chat about? Hey, Dodger.
Yeah, sorry, I was a bit late. I was chatting to call your colleagues actually.
Okay.
I was obviously they're part of the issues that we've seen recently are due in part to the way that light wallets currently work, just their architecture.
Right.
And I wondered, I'm curious as to, is the planned ECC wallets going to be built on that same architecture, or are you looking at doing something different?
At the moment, the plan is to just leverage, like the light wallet D, intermediate server. There have been conversations, I don't think Sean or Nate are on the call, that occurred that have occurred in the past just randomly, not like a concerted effort, that would have a different kind of architecture that didn't require like a light wallet server. But that's quite honestly just kind of over my head to even do justice trying to explain what they were thinking or kicking around. But yeah, to answer your question, the plan as we have it set right now is just to use that same light wallet architecture, hopefully with the improved sync we're about to include in our mobile SDKs. Projects that are built on those SDKs will have some, they'll be acceptable. The sync times will be acceptable for those.
Yeah. The limiting factor for the steady state, for the most part, is detection of new spends, like spends that are from the chain perspective unconnected to anything in your wallet. Everything else can, but there are things we can do and tricks we can play, like the stuff that we will be putting into the syncing stuff that we're doing now, which will then be part of the subsequent wallet. Leveraging all the tricks and things that we can do given the way that the protocol currently operates. But the two things that would be like significant departures from the way that wallets currently operate, I think. One of them would be something more like, if we finally had a suitable detection key style protocol, rolling something out like that, of which there are several potential opportunities now, but all of them essentially require address changes. So it's not something that we can just roll out on its own, at least. Rolling it out would require essentially buy-in on both halves of the connection. Like the sender has to be compatible with those kinds of detection things as well, and creating transactions in that way. So it's doable, and particularly once unified addresses are out and established and people are using them, it's something that could be rolled out on top of that. In terms of if it was, say, rolled into the SDK, then wallets that upgraded the SDK could opt to use give their peers the larger addresses that enable them to then use this other syncing protocol. The other one is more of a fundamental shift in how transactions are synchronized. So right now, people rely on the broadcast medium of the chain to detect transactions. But there's no need for that to always be the case. So if you are at a merchant terminal, you're buying your coffee and you have your phone there, your devices are in very close proximity. You may even be scanning a QR code for the purpose of making the payment. There is ways and means to have an opportunity for the transaction to be sent directly to the recipient, at which point you don't need to do chain scanning. So if you happen to operate a wallet or a detection node, a scanning node or whatever, where the only way it receives transactions are by being literally given them by the sender, then you don't need to do chain scanning in at least the slow part of the chain scanning, because you don't care about seeing that information.
Yeah, but you still need to confirm that specific transaction is in the chain, though. Yeah.
Yes, but that part is not the bit that's slow. The bit that's slow, the slowest part of synchronization is the linear scan of trial decryption of every single output in the chain to find brand new sources. If people have seen my DagSync proto blog that I didn't quite get time to finish before it went public, I've got a note in there about if you think of the graph of your trend of your I can just post the link in chat actually.
Well, something I wanted to point to there also is that what you're talking about with wallets being able to become aware of a transaction immediately. There are also heuristics that we can use. Scan the blocks around the time that the wallet is open first, because the time that someone opens a wallet is the time they're most likely to be anticipating to receive a transaction and so forth. And those kinds of things will absolutely be possible with the changes that are required to make the DagSync work.
Yes, but that's still that's really only changing the order in which you scan things. It doesn't really change the fact that you still have to you can't eliminate the fact that you may have received something without for wallets to avoid that, they basically need to either, like I said, go to a detection key system, which means you can offload the detection in a privacy preserving way to someone else who has the time to scan the chain for you, or you set your wallet up in a way where you don't have to scan the chain.
All right. So Dara, your hand was up, and then Dodger.
Yeah. So historically, one of the reasons we haven't just completely embraced sending transactions out of band is that we want to be able to recover if a user only has the wallet seed, so they have to regenerate all of the addresses and rescan. But I mean, you can, if your goal is to reduce the effort in sort of syncing in the common case, and you can allow a much longer sync process for recovering from seed, then that's not really as much of a problem. Well, provided you still keep the outputs on chain, which does increase the bandwidth needed on chain.
Yep. All right,
my mental model of Strad says that he's about to respond, saying that he wasn't suggesting that we only send the transactions out of bands, that I think he was suggesting that they get broadcast to the network, and also, the information to make it easier to find the transaction is sent to the terminal. Am I right, Strad?
You have a very good mental model.
Yes.
I was also thinking that, but I wanted to give Strad a chance to expand on my point.
Yes, you are absolutely correct there. So I can raise the hand that Dodger noticed I had raised. Yes, that is indeed the case. And actually, another thing that is noted in the DagSync thing is, once you have discovered a new source, you can fold that into your graph. So in the case where you need to do a chain recovery, you still don't need to do the linear scan, as long as you have, if you are in the mode where your wallet is always receiving things directly, so in its steady state, it never has to scan. And then once it receives something, it proactively knits it into its graph. Then you also don't need to do a full linear scan when you recover from seed. You just have to scan to find your most recent things, and then that is good enough. Modulo maybe a section of linear scan at the very end to cover anything that falls through that gap. But for the most part, you can completely avoid it if your wallet from the beginning works in that paradigm.
Oh, right, because you have the keys and therefore you can go backwards because you have...
No, you don't go backwards, Dara. You don't... What I mean is, if you're in the paradigm where your wallet only detects funds, so it never, if in steady state, it never scans the chain, and as in like trial decrypts, everything, and it only detects funds that it was literally told about, like another wallet handed it to it, then once it receives those funds, you just need to ensure that that the funds that you received are downstream of your graph. So your wallet then makes a proactive transaction to merge the funds you received with some existing funds that you are already tracking. So
I see. Yeah.
So then on recovery, you won't necessarily find that transaction that you received it on, but you will find the funds corresponding to it. Right. At which point, the only reason to do a linear scan of the chain is history recovery rather than fund recovery, which can be done with a lower priority.
Yes. Thanks, because I was confused on that. You'd mentioned it before, and I hadn't got the detail right.
Right. Dodger, I think your hand was up for a different reason other than Strad's mental model. So.
I've thought a lot about detection keys, because it could be a little bit of a game changer in terms of, number one, massively reducing the computational and storage load for light wallets, but also the ability to have somebody else do the scanning for you without having to disclose everything to them, without having to breach your privacy to them. I don't know what the best term there is. I think it's really interesting because, at the moment we have limited number of light wallet servers, but imagine a future where there are you have the option to run a detection style service as part of your node, or imagine when you start up Zcashd or Zebra, you have the option, you can include this, and then you could have the drastically reduced bandwidth. You could have a light wallet that gets switched on, maybe connects over Tor, connects to a node, says, tells the node, the last block, that was checked on my behalf was this. These are my detection keys. Can you please check, from either from that block until now, or from that block until another block, and then go out to do load balancing across multiple nodes. So they're doing 1,000 blocks, they're doing 1,000 blocks, they're doing 1,000 blocks. You get all the all the stuff back, and then you assemble it in the light wallet, and you're preserving you're preserving you've strong privacy preservation, because although the nodes know that you're interested in specific transactions, if you're connecting over Tor, they don't know who you are,
right?
You know, so I think that detection keys are a potentially very powerful thing, and something we should maybe do some brainstorming on, or maybe get a workshop together on.
Absolutely,
yeah. Makes all sense.
And that also, by the way, then leads us towards a more decentralized Zcash network. So you think about it right now, there's strong centralization for light wallets. There are a certain number of light wallet servers that are operated by people, and number one, there's a certain kind of central, semi-centralized point of failure, but also potential attack points. Whereas if you have every Zcash node was prepared to do a little bit of scanning for folks, then it would be interesting. Obviously, the computational load of that scanning would be a factor, but you could build in some form of throttling, or even some form of payment. Here's a couple of satoshis. Can you scan 1,000 blocks for me?
Right.
Anyway.
No, that's a great idea, Dodger. A great point. And the other thing too, like a full node that's kind of doing scanning on your behalf. Usually, like a full node is going to have like some pretty, some decent hardware anyway. For the most part, you can run it on a, just a consumer laptop if you wanted. But in a lot of cases, there's some pretty high-powered computers running nodes. So scanning would be, relatively fast compared to like a smaller device or something. Okay, Paku, your hand's up.
Yeah, I just wanted to comment about the transaction or the transacting thing mentioned before. There are a lot of things that we are not, or the wallets mostly are not exercising, which is the mempool things. Currently, like if you like the wallets don't actually monitor the mempool really actively to just show transactions or incoming transactions and all that. So there's a lot of room to improve like perception of transaction speed with that, considering that the mempool it is what it is.
Right.
So yeah, I think that there are things that are less complicated that we are still not fully making or fully profiting for. So it's something that it's interesting to explore before like doing more complicated stuff like off-band transactions and like replicating like at the same time on the network.
Right. Yeah, Dodger commented, I think Zec Wallet Lite looks at the mempool to some degree. Dodger.
Yeah, I could be wrong, and I can't remember the details, but I think it does.
Yeah.
I think it checks.
Okay.
It checks.
It does some. Yeah, it does to some extent. Yes.
I think it's more about being able to spend your change after you send a transaction.
Right.
Yeah, well, that's a transparent thing, because you can't spend shielded change until it's been mined. So the fact that it's in the mempool is irrelevant. But for transparent, that is indeed the case. So if you want to improve the latency of transparent, then you absolutely would interact with the mempool. And also it wouldn't matter because it's transparent. So we're not trying to hide anything there.
Right. Okay. All right. There is a question that came in through the Q&A function in Zoom. It says the increase in the blockchain size associated with the higher volume of shielded transactions is very alarming. Maybe turn off shielded transactions until this is under control. That would definitely stop the increase in chain load, but
no, it wouldn't.
It would. If you couldn't do a shielded transaction, you wouldn't be growing at a gig a day. So we do that, but I think it would destroy the project.
I disagree completely.
Oh, really? Okay.
If the increase in chain load is due to a desire to increase chain load, then transparent transactions can be used for that. The chain growing at the rate it is due to blocks approaching fullness. So blocks, a series of blocks being full. Blocks can be filled with transparent transactions. Turning off shielded has zero effect on that. What it would do is decrease the cost of validating a full block of transparent transactions is going to be cheaper than validating a full block of shielded transactions because you don't have the proofs to verify. So it would be cheaper to verify from that perspective, but that only affects the cost of keeping up with the chain. It doesn't affect the bandwidth cost or the data storage cost.
Yeah. So you'd still have the same amount of data that just be transparent data as opposed to like shielded data, for example. Okay. Yeah. Good point.
Disabling shielded transactions does not have the create the incentives that that would reduce bandwidth.
Yep. Got you. Okay. Paku, I think your hand's probably still up from before. And then Dara.
Yeah, so for the sake of argument, suppose I'm an attacker and my goal is to disable shielded transactions. And we disable shielded transactions in response to this the situation, then I've achieved my goal. So I don't think we should do that.
That's probably not on the short list of things we were thinking. Yeah.
So I have suggested halving the effectively, not as a consensus rule, but as an option that miners can take, effectively halving the block size. I don't know what other people's opinions are about that. It would so it would halve the increase in chain size. It would roughly halve the syncing and validation times. So what are people's opinions about that option?
Yeah, we chatted about that. Had a conversation with Nate and Sean about that once, and the concern was, it's kind of one of the things I mentioned in one of my slides, like there's some different things you could do, but do they cause like other problems that might actually be worse? So for example, if you cut the size of a block down, significantly, and you keep the block time the same, then the amount of data you can put on chain is clearly reduced, right? So that math definitely works out. But does it then create contention for block space beyond what you're seeing now, where let's just call it this, there's a certain profile of transactions that are associated with this increase in load, and then there's kind of normal shielded transactions, if you will. And would it then impact people just trying to send, pay for their coffee at a coffee shop because they can't get a shielded transaction mined or accepted in a block or something? I don't know the answer to that. It's just the type things I think we should really think through.
I have a response. So we effectively doubled the transaction bandwidth with Blossom.
Right.
And
reduce the block time,
by reducing the block time, although the effect on bandwidth is the same as halving the block size. So when we did that, we did so based on an estimate of validation time for a block, what the effect would be on orphan rates, things like that. And I think with hindsight, this situation has shown that we made some miscalculations there. Now I know that those calculations were explicitly based on us implementing parallel verification, which we've done now, but it took a long time to do it. But even with parallel verification, we're still on the edge of sort of what is feasible to cope with in terms of transaction bandwidth. So there's an argument to be made that we did miscalculate, and that maybe only temporarily until we've implemented other changes, we should reduce that effective rate.
Yeah, my point was that I think it's a valid temporary measure.
I did suggest it originally as a temporary measure.
Yeah. But I think you know, in the world that we all hope, you know, exists in 5-10 years time, we'll have far more transaction volume than this. So I think it's in a way, you know, I think I've said this before. This is actually a really, really good thing to have happen in many ways, because it's forcing us to improve things, you know,
in some ways.
So I was going to say, I'm going to channel Dodger's mental model and say that this is actually a good thing, but you beat me to it. So I knew you were going to say that. So I've heard that before from other people. It's like, hey,
we know each other too well by now.
Yeah. Yeah, cool.
Predict what each other's going to say.
Yeah.
I try to be predictable. I don't try to be to give you surprises in my technical opinions.
Yeah, and we're definitely getting to significantly better positions than we were at, and like even like the full node stuff that we've done thus far, there is still more that we could potentially do. It's just more, you know, doing that more would take significantly longer to implement, and you know, there's a time opportunity in terms of, like, you know, we spent a bunch of time working on the full node. Now we have to spend a bunch of time working on the wallets, and you know, but that's not to say that there aren't some longer tail things that we can do to the full nodes, even you know, for the current behavior to improve performance.
It is also worth pointing out that effective block size decrease can be implemented using options that are already in Zcashd. So miners can just do that on their own. But I think they're probably only going to do it if we tell them to.
All right. Yeah. I would also, you know, this is obviously a little bit longer term, but I'd love to see like options with, you know, Halo 2 and recursion around transaction aggregation or block aggregation. And then, you know, then the type load Dodger's talking about, what we hope to be in 5 to 10 years is going to be just organic growth beyond what we're seeing now. We've got a scalable solution for, you know, the next wave of load that we might encounter.
Yep.
All right, very good. All right. Anything else? I think we got all the questions answered. Got the one in the Q&A section addressed. So I think we're caught up in chat.
Yeah, so there has been a proposal to change fees to make them sort of roughly proportional to the number of inputs plus outputs. That's been Aditya of Nighthawk, I think, has filed that as a draft zip 317. So I would encourage everyone, if they have opinions about that, to look at the draft zip and comment on it if they want.
Yeah, good point. Yeah, and as I mentioned, I kind of flew by it in the bullets up front, but you know, one of the things Nate's kind of shifted his focus short term on is like theme mechanism research to see if there would be options. You know, he's going to be reviewing Addy's proposal and some other ideas. And, you know, I mean, Nate's he's been like looking into EIP 1559 kind of things forever, you know, as it might apply to Zcash. So just trying to merge up that background work he's been doing with, you know, just understanding Addy's proposal a little better. And are there some options we could implement that would be, you know, again, under the heading of, let's don't create a UX nightmare around fees, make sure they're effective, make sure they're fair, you know, and they're proportional to what you're kind of trying to do. So yeah, so definitely to Dara's point, take a look at that. I think it's zip 317 Dara that was assigned, and it's of course a draft PR at the moment.
Yeah, it's a draft PR.
Yeah,
Right.
I can't seem to post to everyone in chat. I can only post to hosts and panelists, so I can't put it into the section where people just listening could see. But the PR number is it's PR631. So the URL is github.com/zcash/zips/pull/631. If people want to comment.
Yeah. Okay. That little in the to section, sorry to just total rabbit hole, but in the little chat box, there's it says to.
Yeah, I know.
Yes,
I've only got hosts and panelists. I don't have everyone, but it looks like Taylor has an everyone option. Yeah.
Okay. Wow, that's weird. Okay.
Yeah. That's changed. I think it might be the new version of Zoom.
Okay. Maybe it's an update.
Interesting.
Cool. Yeah. Thanks, Taylor. Yeah, I was about to go track it down. So. All right. Very good. Well, look. Yeah. Everyone have a good rest of the day. Good weekend. Sorry I missed Dodger. I said before you got on the call. Sorry I missed everyone at ZCon 3. My wife tested positive for COVID the Wednesday before I was going to leave on a Friday. And I didn't feel it was like super responsible to be, because I was obviously exposed running around, on a plane or in a conference.
Did you catch it, Stephen?
No, I'm good.
You didn't.
Yeah, she's all better, has a tiny little nagging cough, but everybody else avoided it. So
also she might not have appreciated you going, oh, you caught COVID. Oh well,
right.
I hope you feel better. I'm off to Vegas.
I'll be gone for a bit, and you'll probably be better when I get back. That would not have gone over good.
Oh man, sure. you'd have come back to all your clothes at the front.
They'd have been in the drive. Yeah, so.
I don't think the Cleveland Report attendees of Zcon would have been very happy with you either.
Right. No, but nobody would have been glad to see me. I don't think so.
No.
Anyway. All right. Well, y'all have a good rest of the day, good weekend, and we'll catch up in Discord.
Okay.
Right.
See you.
Take care.
Bye.
Thanks. Bye.